Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In my channel I deal with the different aspects of mathematics, physics and chemistry. And in most of our discussions we normally do the theoretical work on various concepts and try to see how we can be able to, of course, analyze them and define them in various ways. So in this particular aspect as well, we do some of the practical questions on various topics that we have tackled. And in our case today, we're going to look at the concept of coordinate systems, and this basically is going to form a third bit and the last part of the spherical coordinate system that we had mentioned. And of course, I'm going to do this using the specific services that we had mentioned earlier, and then of course a various range of variables that are going to assist us try to differentiate this one from the previous two types of systems. Now, I normally put a link of various videos or related videos in our description boxes for various videos. And I like to encourage our members also to check on the same and try to see how we can be able to assist one another in trying to understand these various concepts. Now, the spherical coordinate system is going to be defined using three fundamental services. And these services are going to be defined by a sphere, a cylindrical right corner, and then we're going to see that there's going to be a half plane that is going to be perpendicular to the XZ planes. Now I'm going to use an illustration on the board in order to, of course, illustrate or rather try to visualize these specific services that I've mentioned. So on the board I've given a set of three illustrations. I can just give them for A, B, and C respectively so that they can be able to assist us to find this specific set of the spherical coordinate system. And as we have said from the first case, the interaction between these three sets of services are going to assist us define the spherical coordinate system. Now, the first one is going to consist of a range. Of course, I've given it in terms of this specific case, and I've given an imaginary axis for x, z, and y respectively. And I'm going to mention why I've done as such. So we're going to have a sphere of radius r from the origin, which is going to be centered as the origin and having a radius r as such. And the second one is going to consist of a cone, a circular cone, which is going to form its apex at this specific point of the origin that I'm going to give as O. And then we're going to see that this is going to form a particular angle that is theta at this specific point. And this is going to form a half angle. And of course, we're going to see that its space axis is going to be located along the exact axis. So therefore, we're going to see that this particular range of theta is going to have some a set of what we refer to as the range, and I'm going to give that one. So that set of services that is going to assist us define the spherical coordinate system is this half plane, which is going to be perpendicular to the xy plane. It's going to form angle phi that is located at this specific point as I've given. So for the first one, as I've said, is going to be a sphere, and this is going to be having a range of between. So this set of values for the variable of r is going to be contained within 0 and a positive infinity given as such. And for angle theta, as I've said, this is going to range between 0 and what we refer to as, so this is going to be 0 and what we refer to as pi. So this is going to be theta. It's going to range between 0 and pi, which is 180 degrees, which is forming a half angle as I said. And then lastly, for the range of phi, which is going to be a half plane that is perpendicular to xy plane, it's going to form a range of values between 0 and this is 360 degrees. We are going to give that one in terms of radians, which are going to be 2 pi. So in that case, this is the interaction between these three services are going to give us the spherical coordinate system. And I'm also going to give a specific illustration that is going to assist us, of course, see how the interaction between these three services are going to result in the formation of that spherical coordinate system. So on the board, I've given two sets for A and B, and these are going to, of course, assist us in try to interpret in the three-dimensional perspective of this interaction between these services to form the spherical coordinate system. So I'm giving this axis in terms of those imaginary points, and they're going to assist us, of course, try to define. If you try to look at this specific case for this spherical illustration, we're going to have these two angles, which are going to be measured in radians. This is phi and theta, which is the angle between this specific case for this extension. The half angle that we define that is ranging between 0 and 180 degrees is going to be given as phi. So this specific angle is the half angle for this cone that I've said, of course. And we're going to see that the interaction between these three surfaces is going to be defined by this specific radius for r, which is a constant, of course, which is the radius of a sphere that is centered as the origin. And we're going to also define this specific theta for the right cone with the apex, the origin, as we said, which is an half angle that I've mentioned. And then we're going to have lastly phi, which is going to be, of course, perpendicular to the x, z, y plane. And this is the angle that is formed by extension of this specific zx plane to this specific point at that particular range of phi that I've mentioned. Sorry for that. So the interaction of the radius and the theta is going to form a horizontal circle that I've given, which is having this specific curvature and that imaginary line, that specific center. So therefore, this aspect of theta is going to be a constant surface, and then we're going to define this specific radius at this particular point, which is going to be from a right angle, our right rectangle, and therefore we can be able to define that one as an aspect of the r is the sine of theta from basic trigonometry. So in this case, these are going to, of course, assist us try to define this specific spherical coordinate system. Now I'm going to just have perhaps particularly a third illustration that is going to assist us perhaps at this lower part of the. But in our case as well, we can be able to use this specific illustration for A in order to define the point P, which is going to contain the elements of this specific point for r, theta, and phi, just given as the first bit for the rectangular coordinates and the cylindrical coordinate systems respectively. So this is going to be forming that specific point of interaction between those three surfaces as illustrated on the board. So catch us in our next video where we're going to look at the specific applications of various areas of the spherical coordinate, the cylindrical coordinate, and the Cartesian coordinate system that we have just mentioned. And of course, that is going to be more elaborate and great for us a true picture of the applications of these various coordinate systems that we have discussed. So that is it for now, guys. Bye. God bless you.